These reactions, I highly suggest you can draw the mechanism without looking at my notes, without looking at the book. If you study the calculus, it goes through the theorem. The first job is you understand the theorem and you start using it, right? Same thing for the organic chemistry. This is a theorem. You understand what it is. Once you understand how these things go, how you drive things, then you can use that for any other problem that you can see later. You got to treat organic chemistry like mathematics. I know you hate mathematics. That's why you hate organic chemistry too. But this is something that you should be able to do well. So let me show you how things go. You got the carbonyl, the ketones, react with an amine, nucleophile. Typically, we add a little bit of proton because to make an oxygen protonated, that will increase electrophilicy. But this reaction can happen even without the proton. So that's not the necessary part. Anyway, if the proton's available, you got that protonated, you got the oxygen positively charged, that makes the carbonyls even more efficient. The nucleophilic amine makes an attack to the carbonyl, right? And then electron pairs to the loss of oxygens. So you got the protonate amine and a neutral alcohol right here. So what happened? Proton transfer. Proton transfer from here to there. Now you have a water sitting on it. Nitrogen has a lone pair. So these lone pairs are coming in, making carbon nitrogen double bonds, and kick these waters out, and if this proton goes away, you get imine. This is a formation of the acetal, but you can see that there's a cyclic acetal. And let me show you why these things are useful later. But let me first show you how this works. This is ethylene glycol, which is very common chemicals, like preservatives or the anti-freezing solution that you can pour into a car, whatever. That have two hydroxyl groups there. So alcohol, two of them in the one molecule. Protons makes the carbonyl more reactive. One of the hydroxyl groups makes an attack, just like we discussed, and then you got the OH here, right? That one from this side, and then you got these ethylene glycol sitting on there. Proton can transfer the position here to there, right? So if the proton transfer happened, you got the water molecule sitting right here. That's going to be the leading groups. So oxygen lone pairs are coming in, and that makes a carbonyl and kicking the water out. But that makes this carbonyl alkylated, so oxygen is going to be positively charged. That still makes electron deficient carbon right here. So the second hydroxyl groups, or second alcohol, makes an attack, and then finally you get cyclic acetal. So this is something that I really want you to be able to draw the full mechanisms. And that shouldn't be too hard. You just follow the same. This same thing happens over and over again. Imine formation, hydration, acetal formation. It's kind of going through the very same way. In the initial nucleophilic attack, proton transfer, right? Then something leaves again, and they make the carbonyl, and then another nucleophile comes in. It's always like this. But what's more interesting is, can you draw the mechanism backward? Let's say you got the cyclic acetal. You dump this thing into the acidic water, then this will go all the way back from the starting point. You get the carbonyl of the ketoaldehyde and a true alcohol. That's a breaking of the acetal in water. And then they do the same thing. That's why this becomes a reversible reactions. The protonations will happen the same way. Oxygen will be protonated. Then what happened was the oxygen has a low pair, so it comes back, make a covalent double bonds, and kicking these parts out. Once you form that, you're going to have an electric efficient carbon again. That's what water makes an attack. And then once water makes an attack, you can see that this proton can be transferred to over there. Now that can leave, but a cis coming from the low pair of an oxygen. That makes a carbonyl. And then kicking this ethylene glycol out, and then proton goes away to solvents, you get this. So there's a breaking of the acetal with the ketones and aldehyde again. This is kind of the thing that's happen back and forth. Glucose